Antiderivatives, Part 2. Recall the power rule. The antiderivative of x to the p is x to the p plus 1 over p plus 1 as long as p is not equal to negative 1. We also said the antiderivative of 1 dx is just x plus a constant. And if you have a different coefficient, like if you have 5 dx, then the antiderivative would be 5x plus an arbitrary constant. A rule I want to look at today is the constant multiple rule and the sum rule. Suppose we have this function and we want to find the family of antiderivatives for this function. Well, this is what I get. This is the family of all antiderivatives. Now, where did I get this? Well, the antiderivative of x squared is x to the 3 over 3. The antiderivative of x is x squared over 2. And the antiderivative of 5 is 5x. And so I clean it up and I get a family of all antiderivatives of my original function. So the antiderivative of 3x squared minus 11x plus 5 is x to the 3 minus 11 halves x squared plus 5x plus an arbitrary constant. And you want to check that the derivative of your result is your integrand. And just a reminder, all antiderivatives are of this form plus a constant. And so you've got a whole family of antiderivatives that differ only by a constant value. Suppose you have this antiderivative. We do not have a product rule for antiderivatives. And so to do this integral, we need to first distribute 16x. After you distribute the 16x, then you can integrate. You integrate, and after you integrate, you simplify. And then always it's recommended that you check your work. How about this? It looks like a quotient. Well, we do not have a quotient rule. Instead, you need to simplify the quotient. After you simplify, you can integrate. The antiderivative of x to the 17 is x to the 18 over 18. Antiderivative of x to the 4 is x to the 5 over 5. And then you simplify. Let's talk about trig functions. The better you are at knowing your derivatives, the easier it is to remember the antiderivatives. Let's just look at a few. The antiderivative of cosine of ax is equal to 1 over a sine of ax. Antiderivative of sine is negative cosine. Antiderivative of secant squared is tangent. And we know these antiderivatives just because we know the derivatives. For example, antiderivative of cosine 5x is equal to 1/5 sine 5x. Antiderivative of sine 3x plus cosine 5x. Well, let's see. Antiderivative of sine is negative cosine. And the antiderivative of cosine is sine. How about secant squared? Antiderivative of secant squared is tangent. Now, suppose I tell you that I have some mystery function that has two properties. First of all, its derivative is x squared minus 2x. That's its derivative. I also tell you that at 1, the function is equal to 1/3. The function f is equal to 1/3. Well, first thing you do is you say, okay, well, I know how to find antiderivatives. So I'm going to look at all antiderivatives of f prime. So antiderivative of x squared is x to the 3 over 3. Antiderivative of x is x squared over 2. And the 2's cancel. So I have a whole family of possibilities. But right now, I know that f of 1 equals 1/3. And so in my function, I put in 1, and I say that's equal to 1/3. And what this allows me to do is it allows me to find c. So c, in this situation where f of 1 equals 1/3, c is equal to 1. And so I just replace c with 1. And here's the idea. F prime has a whole lot of possibilities, but only one of the possibilities will go through the point 1/3. And so we have all the general solutions, but the red is the specific solution where f of 1 equals 1/3. You take care and have a great day.